And some of these stories are quite good. Here is a representation of a typical winter sky. And if you look at the stars here, winter is dominated by the constellation of Orion the Hunter. This is the winter sky. In mythology, not only is Orion a hunter, you can see that he's attacking a bull. The V shape of stars here is called the Hyades. That represents the head of the bull. In fact, this star, Aldebaran, the word literally means eye of the bull. In fact, you can make out the horns of the bull there. So Orion is attacking a bull. But not only is Orion recognized as being a hunter, he's a bit of a philanderer as well. There are 7 maidens on the back of the bull, and those maidens are called the Pleiades, 7 sisters. Here is the mythological depiction of these 7 maidens, and over here are the actual stars that represent these maidens in the sky. It's actually a young group of stars. You can see 7 of them with the naked eye. There's about 200 or so if you look at a small telescope. Now, in mythology, Orion is chasing these maidens across the sky. And you can see that as you see the sky unfold. As the Earth spins on its axis, then these constellations appear to move in the direction of west, and Orion is constantly chasing them, but never catching them. Now, if you read the full story, then you'll find out that Orion eventually dies by being killed by a scorpion. Now, if you look carefully, the scorpion is not actually in the winter sky. There's a star map of the sky. There's the constellation of Orion. Now, don't worry about these coordinates here. We'll talk about the coordinates of declination and right ascension in a little bit. But this is just a map of the sky showing you the different constellations of the seasons. Orion is a winter constellation. If I draw a line down, you can see the time, the sidereal time, when that constellation appears. And if you look for the scorpion's actually over here in the summer sky. And there's the time that it appears. So why are they linked together in mythology? Well, if you read the time difference between those two, you can see that there's approximately 11 hours difference between those constellations in the sky. And what does that mean? Well, Orion's a constellation of the winter time. So as Orion is setting in the west, as Orion is getting lower down in the sky, as Orion is fading away, up comes the scorpion from the east on the opposite side of the sky, rising into the sky, rising in prominence as the hunter fades in the west. And so you can see these mythological stories played out in the nighttime sky as the seasons pass by. Okay, so there you have it, the different constellations that you can see throughout some of the seasons. Now, from our perspective, we don't really appreciate fully what's going on. For instance, if you look at the famous constellation of the Great Bear, Ursa Major, you can see a recognized pattern of stars in the sky called the Big Dipper. I'm going to mark out. It looks more like a saucepan in the sky. And there's the pattern of the Big Dipper. Now, each one of those stars is a different distance from the Earth, and we just really don't get any kind of idea as to the distances of these objects. Like, for instance, if you start marking off a few of these stars, there are 2 stars there. The fainter one is called Alcor, and the brighter one is called Mizar. Now, if I were to tell you that the distance between Alcor and Mizar was 3 light years, you could get a sense for how much a light year is on the pattern of stars in the sky. Now, the next star along in the handle of the Big Dipper is the star Alioth. You can see it's quite bright there. And I can tell you that Alioth and Alcor are actually 6 light years apart. And that just doesn't seem to make sense, does it? How can this star and this star be 6 light years apart whenever these two stars, which appear very close together, are actually 3 light years apart? Well, in order to get a sense for what's going on, you need to be able to understand the full distances. So if we look from the perspective of the Earth, here's where the Earth is in space. It turns out that Alcor, if I draw a line to Alcor, Alcor is here in the sky. And my Alioth is up over here in the sky. Their separation is about 6 light years. Now, from our perspective, we can actually draw a triangle there, and you'll find out that the angular separation of those two stars is about 4 degrees. And if you measure that angle, you'll find out that the tan of 4 degrees is equal to 6 divided by 81. And that's because both of those stars are around about 81 light years from the Earth. Now, why does Mizar appear so close to Alcor? Well, it's actually just in the same line of sight. And if I were to mark it off in this diagram, we just change the color so you can get a better idea. Mizar is around about here. So it appears close together in the sky, but it's actually only 78 light years away from the Earth. So it's 3 light years closer, but pretty much in the same direction as Mizar. And we just don't get that sense when we're looking up into the nighttime sky. Some stars can appear very close together, even though they are very far apart. But you get that sense for what's going on. Now, the first person to sit down and start to record the stars in the sky and put some sort of scientific definition to them was the first true astronomer. His name was Hipparchus, and he is recognized in history as the first person to start cataloging the stars. Now, if you look up into the heavens, you'll find out that the brightest stars have all got names. So here is the constellation of Orion. There's the shoulder of Orion. That star is called Betelgeuse. And then down over on the other side, you'll see the foot of Orion. That's called Rigel. Now, the brightest stars in the sky have got names. The vast majority of those names are actually Arabic names. Betelgeuse doesn't mean anything in English, but in Arabic it means armpit of the giant. And Rigel doesn't mean anything in English, but in Arabic it actually means foot. And the reason why they've got Arabic names is because during the Middle Ages, when the Greek writings fell away from prominence, the center of learning shifted into the Arabic world. And so we get a lot of the ideas from the Greeks translated through Arabic astronomers, which is why the vast majority of the names of stars in the sky have got Arabic names. Now, what Hipparchus started to do then was he started to classify stars. And originally they were classified according to simply the letters of the alphabet, usually being with the Alpha star being the brightest in the constellation, Beta star being the next, and so on and so forth. That's not always the case. Sometimes the Alpha star isn't the brightest. Sometimes it's simply the most prominent star in the constellation, or it means something in terms of what the constellation represents. Now, what he did was he started to classify the stars, and he said that the brightest stars were stars of first magnitude. And then he said the ones that weren't just as bright, we'll call those second magnitude, then third magnitude, fourth, fifth, and then the faintest stars that he could see, he called those sixth magnitude stars. Now, we still use the same system that Hipparchus used in the past. It's typically the way science works, but we have made it much more scientific. We start off with the same idea that the faintest constellations that you can see are sixth magnitude. But in order to make it much more scientific, you've got to use instruments to measure the brightnesses of stars, because the human eye is not very good at doing it. In fact, when you're looking up at the stars, if you were to look at two stars close together and you considered them to be about 5 times difference in brightness, a machine would actually measure them to be about 100 times difference in brightness. And so what astronomers have specified today is that 5 orders of magnitude equals exactly 100 times difference in brightness. You can see that if you actually look at it in the nighttime sky. If you pick out the belt stars of Orion, which you can see there, the bottom 2 stars are very, very similar brightnesses. The bottom one is called Alnitak, and the middle one is called Alnilam. I would dare you to have a look at them in the nighttime sky and tell me which one you think is the brightest. It's indiscernible to the human eye. The third star, Mintaka, is easy to see that it's actually a fainter star. Now, when we make this scientific system a bit more rigorous, you'll find out that rather than going to first magnitude as the brightest object in the sky, you end up going into negative numbers. So the brightest object in the sky is minus 26.7. That's the sun. There's nothing in the sky that's brighter than the sun. The next brightest object in the sky is the moon. Its magnitude is around about minus 12. The brightest star in the sky is Sirius, minus 1.45. So we make it much more scientific, but it makes it a bit more confusing because you can go to 0 magnitudes and then you can actually go into negative numbers as well. So if you go into a computer program like Stellarium and you click on a star, it will actually give you the magnitude number of that star.